about is arguably the most important part of particle physics, the quark. Now, what exactly is a quark? Well, a quark is a fundamental particle with no internal structure that makes up particles that are hadrons, or protons and neutrons, which react with strong forces and have internal structure. And I'm going to explain it using cake. So let's get started.
So we know everything is made up of matter, and what makes up matter is atoms. And what mostly makes up atoms is protons and neutrons. But what exactly makes up protons and neutrons? Well, a subatomic particle called a quark. Now, these subatomic particles, known as quarks, exist in what are called flavors. And there are 6 different types of flavors. So the first one, or the first flavor, is the up quark. The second flavor is the down quark. The third flavor is the top quark. The fourth flavor is the bottom quark. The fifth flavor is the strange quark. And the sixth flavor is the charm quark. And these flavors are almost like flavors of cake. Now let's talk about how quark flavors relate to cake flavors. The up quark relates to vanilla cake because when I look up at the sky, I see fluffy white clouds which remind me of vanilla icing. The down quark is chocolate cake because when you look down at the ground you see dirt, which is brown, the same color as chocolate cake. The top quark is cheesecake because the top quark is the heaviest type of quark and cheesecake is the heaviest type of cake. The bottom quark is a cupcake because only the bottom is made of cake. The strange quark is strawberry cake because strawberry is more of a strange, uncommon flavor. And the charm quark is ice cream cake because the charm quark disappears really quickly. And ice cream disappears really quickly too because it melts. Now, what do protons and neutrons have to do with the quark? Well, protons are made up of 2 up quarks and 1 down quark. And neutrons are made up of 2 down quarks and 1 up quark. So if you remember what we talked about earlier, the up quark is vanilla cake. So, a slice of vanilla cake, including the frosting and everything, would be a proton. But inside that frosting, that piece of actual vanilla cake would be your quarks. And because an up quark makes up most of a proton, then the proton is the vanilla. And because down is chocolate, then the entire piece, frosting and all, of chocolate cake is your neutron. But the actual layers of chocolate cake inside would be your down quarks. And because a neutron is mostly all down quarks, the chocolate cake represents the neutrons. So in summary, the nucleus would be almost like a chocolate and vanilla layered cake, made of neutrons and protons, or chocolate and vanilla cake, stuck together into layers, full of up quarks and down quarks, which make up those protons and neutrons. Now, another thing to know is that quarks carry partial electric charges. The up quark has a positive 2/3 charge, and the down quark has a negative 1/3 charge. I like to think of this as if you were actually baking the cake. So if you were actually baking a vanilla cake, you would probably need about 2/3 of cups of vanilla extract. But to make chocolate cake, if you accidentally poured in that vanilla extract, you would have to figure out some way to remove at least 1/3 of that vanilla extract, because it's chocolate. You don't need that much vanilla flavoring if you were making a chocolate cake. Next, let's talk about gluons. Gluons are teeny tiny massless particles that transmit forces and bind quarks together. Gluons act as if they were the icing between layers that bind the cake layers together. So essentially, gluons act like glue in holding quarks together, or holding layers of cake together. So just to reiterate, gluons are the tiny subatomic particles that bind or hold together different types of quarks. Now we can talk about color charge. Quarks carry what's called a color charge, which they use to bind along with gluons. The 3 color charges, red, blue, and green, emit and absorb gluons, which maintains a proper color distribution, or creates a neutral colored quark. But remember, these colors are not meant to be taken literally. Quarks are not actually colored red, blue, and green. They're just used as labels to represent the other non-electric charges that quarks can carry. And as I have previously mentioned, these colored charges are not electric like we typically have electric charges. These colored charges actually are of strong interactions and strong forces, which are one of the many different types of forces. Now, in order to remember the 3 different colors, I like to think of them as the ingredients needed to make the cake. So red would be sugar because sugar typically comes in a red package. Blue would be flour because flour typically comes in a blue package. And green would be eggs because everybody loves green eggs and ham. And you mix all these ingredients together and it creates a whole, regular, or neutral cake. What else? Quarks only exist in groups of 2s or 3s. Antiparticles exist as the same particle except with opposite charge. Quarks are just one of the many different types of subatomic particles, and electrons exist as subatomic particles called leptons. And now, you know all about quarks, one of the most important and awesome fundamental parts of particle physics. Again, my name is Kaylee, and thank you so much for watching, everyone. I hope you enjoyed.